Hello, welcome to another session of DevSpace webinar series. Today we'll be discussing about the in-app purchasing API provided by the Zenit Mobile Telco application platform. First of all, let me introduce myself. My name is Pasun Javadana. I'm a software engineer here at Zenit Mobile.
And I'm Jay Krishnan, software engineer at Zenit Mobile, and I will be doing a live coding session on in-app purchasing.
Alright, before getting started on the in-app purchase API, let's take a quick recap on what we have learned so far on DevSpace and how you as a developer can benefit from it. If you want to follow our previous webinars in detail, you can do so by visiting devspace.zenitmobile.com after this session. So there are 5 simple steps to creating a telco application in DevSpace. First and the most important is that you have to have an application idea. Once you have an idea, second step is to choose the method of creating that application. DevSpace provides a variety of APIs for you to easily connect with a telco operator's assets. The APIs would range from SMS API for messaging applications, USSD API to create apps with quick access via USSD menus, location-based APIs that allows you to locate places and people, and charging APIs which allows users to make payments through their mobile account. Alright, once you have chosen the necessary APIs, the third step is to develop your application and test it. We provide simulators that enable you to test your application on a mock telco environment. Once the application is tested and ready to go live, you come to the fourth step, which is to deploy your application with a chosen telco operator. DevSpace allows you and your application to go global with telco operators around the world and gives you the opportunity to make their subscriber base yours. Fifth step is to market your application. This is a crucial step in order to grow your application's user base. Alright, so these are the 5 steps that you need to get your application off the ground. Now all you got to do is sit back and enjoy the revenue you get from your telco subscribers. Okay, now that everyone is up to speed with how DevSpace can benefit you, let's go ahead and dive into the newest addition to the DevSpace API family, the in-app purchasing API. During this webinar, we will be speaking about what is in-app purchasing, how can in-app purchasing help to grow your application revenue, how does DevSpace in-app API work, how to get the in-app purchase developer toolkit, and Jay Krishnan will do a coding session on how to integrate in-app purchase with your application in 10 to 15 minutes time. And finally, we will be wrapping up with mentioning all the benefits that you can get from integrating in-app purchasing API in your application. So let's say you have this great application, but your only source of revenue from this app is only when the users buy your application. That means from a particular user, you get only one chance to earn revenue. For all the hard work and time you put into this application, that just might not be enough. What if you can turn this one-time sale into a steady, ongoing stream of revenue? Now this is where in-app purchasing comes into play. In-app purchase API gives you the ability to set price points for different items, services, and features that you offer inside your application. For example, it can either be used to buy coin packs inside a game or to unlock a certain feature in your application. So you are able to have multiple sources of revenue in just one application. Now since your application has multiple revenue sources, you can go ahead and make a smart business decision by making the application free or lower the application price. That way, more users would be willing to download your application instead of being frightened or unreluctant by seeing a heavy price. Have you ever wondered how most of the top grossing apps on mobile app stores are listed as free, but yet they generate so much of income? Well, it's all thanks to the beauty of in-app purchasing. So the users can download the application, enjoy some of the features of the application for free, and pay for other services when they are satisfied. This way, your application would get a much more loyal user base as well. Traditional in-app purchasing APIs have support for payments through credit cards only. But did you know that in mobile payments, 80% of the time, consumers prefer paying by their prepaid or postpaid mobile account rather than using their credit cards? The reason for this is that payments through a mobile account feels more secured and convenient for a user. and majority of the time, people are reluctant to use credit cards for application purchases. So why not enable in-app purchase with user's mobile account? DevSpace in-app purchasing API does exactly this. By tapping into the telco operator's charging interfaces and combining it with in-app purchasing, our API takes the traditional in-app purchasing APIs into a whole new level. The end result is a safe, convenient, and a seamless purchasing experience. Now, let's take a look at the types of in-app purchases that you can use in your application. Mainly, there are two types of in-app purchases. First is consumables. Consumables are the type of purchase that you would do again and again in an application. Once you use or consume the particular item that you purchase, you would have to repurchase it. Common examples for these types of in-app purchases are the virtual currency inside a game, or gems, food items that you need to consume throughout a game. The next type is called entitlements or durable purchases. These are the exact opposite of consumables because these purchases are only made once. Once you buy it, you are entitled to that purchase forever. Common use cases for entitlements are unlocking a certain feature inside an application, or upgrading a trial application to its full version, or buying an issue of a magazine or a newspaper. Okay, now that we all know about in-app purchase, let's take a look at how your application would function in case of an in-app purchase once you integrate it with the DevSpace API. Okay, what you see now is a sample game that we've created for this demonstration called DevSpace Invaders. It's been integrated with the DevSpace in-app purchase API. Okay, here you can see that I have 0 coins with me. Therefore, I am unable to proceed to any of the next levels. So, I have the option of buying two types of coin packs here. The first pack gives me 5,000 coins for 99 cents, and the second pack gives me 12,000 coins for $1.99. I'm gonna go ahead and select the 5,000 coin pack. Alright. Now I get the pop-up asking me whether I want to proceed with the purchase. Once I select continue, it shows me the mobile payment methods that I can choose from. Whether I want to pay from my mobile account or maybe using my mobile wallet. I'm going to select mobile account. And voila! It says my purchase was successful. And you can see my coin balance is now 5,000. So you see the whole experience was quick and seamless and doesn't make the user hesitant to make the purchase. So without further ado, I'll let Jay Krishnan to demonstrate on how to integrate in-app purchase with your Android application.
Alright guys, so far we have been showing you about in-app purchasing with telcos. Let me explain how the actual magic happens in the background. First thing you should know about is the Telco Android App Store. If you see the current trend, most of the telco operators are moving with Zenith Mobile Telco application platform to create their own telco app stores. These telco-centered localized app stores are getting more and more popular over others because they tap directly into the telco operator's assets and give users a seamless app store experiences. One such example of this would be the payment of purchases via subscribers' mobile accounts. These localized app stores are very much user-centered and users feel much more safer with extended control over their information. Next thing you should know about is the in-app purchase Android SDK. You can use this with your Android application in order to enable in-app purchasing with telcos. It only takes few minutes with a couple of steps to integrate your application with this SDK, as I'll be demonstrating to you in a moment. Once your application user installs your application and the telco app store into his Android device and makes an in-app purchase, the SDK creates a connection with the telco app store and create an in-app request specific to that user and send the request to the telco app store using the connection. Now, the App Store receives the request and comes over your application to ask the user for confirmation. Once the user selects the payment option and confirms the purchase, it sends the request to in-app service. There, the transaction completes and the in-app service generates in-app response and send it back to Telco App Store. Then the Telco App Store informs the user that the transaction has completed and at the same time informs your Android application about the transaction status. And then it's all up to you to give the requested feature to your Android application users. Okay, switching back to my desktop. In this session, I am going to show you how to enable in-app purchasing feature into your Android application. So we will be using Telco App Store Simulator and in-app Android SDK, and I am also having the Java docs for our SDK. We will be using IntelliJ IDE Editor, open it up, and there I have created a simple Android module named in-app sample. So let's have a look on our in-app sample module. It has an Android activity called my activity, and there we set a layout main.xml. So let's imagine this application like a game, and the goal of this activity is to show our users how much of coins they have. So here we have a purchase button saying buy 100 coins for 0.01 USD. Once the user click on this purchase button, do in-app purchase and update 100 coins on this view. To do this, switching back to my activity, here we want a purchase button. So let's call it button purchase button. And the text view, call it coins count text view. So let our editors to import the Android button and text views. And from our onCreate method, we will be getting the purchase button called find view by ID or .id.btn purchase, and let it cast to Android button, and the text view find view by ID and text view coins. Yes. And cast it to text view. In our activities onCreate method, set an onClick listener to the purchase button. So when the user click on this purchase button, we can start the transaction from new onClick listener. So far we have done the basic frame, and now it's time to integrate with our SDK. Open up project structure, library settings, and add a new library, and there select our in-app Android SDK. Okay, and if you want more help, you can also add our Java docs and apply it, and there we go. So remember, the very first thing we have to do is to listen to in-app SDK. Okay, what that means, our first step of coding is to implement, type in-app, and you can see all the options: in-app request, in-app service connection, request factory, connection factories, and there we select in-app service listener, and now our activity implements in-app listener, and you see it shows you that implement abstract method on in-app response in in-app service listener. So again, let the idea to implement the method. Okay, don't worry about this, we will come back in here later. Now back to our purchase button. When the user click to purchase, forget about the SDK and think what you want to do. You want to create an in-app request, and we want the in-app connection, and we have to send the request through the connection, and finally we expect the response from our connection to check whether the transaction is success or not. So there, on in-app response, we will be receiving an in-app response from our SDK. So let's start with the first step to create an in-app request. So type in-app and see what are the options. In-app charging requests, there we go, and call it request, and use in-app request factory. So you can see create charging request method there. So let's look at this documentation of create charging request. It shows the parameters and application ID, application name, application key, and application external transaction ID, amount and currency, and all the explanations are there. So for this session we can give some dummy values because we are working with the simulator. So let me give an app ID app 1 2 3 4 5 6 and an application name. Let us call it the sample application, and we have to give a application key. So for this we just give a dummy application key for now. Say application key and type *** that you will be getting from the provisioning. So type an external transaction ID so that you can use it to verify your transactions. So for now just give a dummy number. The next argument is item name. So we call our in-app purchase item coin packs, and the item detail, say buy 100 coins. And next we have to give the amount of our in-app purchasing item. So our coin pack will cost $0.01 US. Now we have the in-app request. So next step is to create an in-app connection. So type in-app and select in-app service connection. Let's call it connection, and again we have the factory method in-app service connection factory, and there you can see two methods, create simulation connection and create connection. So for this session we'll be working with simulator, so let's select simulation connection, and once you're done with the testing you can just switch it to create connection that will work with the real in-app server. So let's see the documentation of create connection. It takes the Android activity as an argument. So let's check our activity is my activity. So we have to pass the connection or activity as an argument, my activity dot this, and let me make it more readable. So now we have created the connection and the request. So the next step is to send our request using connection dot send request and pass our request there. And we are done with the purchase button clicks. So once the button is clicked, the in-app request get executed and the SDK will call back you using on in-app response method. So there we receive an in-app response. So check if in-app response dot is success. So the purchase completed successfully. So there what we have to do, so we have to update our coins count view. So first get the current coins. Let's say int coins count equal coins count view dot get text, and let's get it passed from integer.parseInt. So we want the integer value to do the additions. So let's add 100 more coins to our coins count and set it back to our coins count view dot set text, and don't forget to get to string value and string the value of coins count, and that's all. So now we are done with on in-app response, and we are done with the coding now. So we have created the request and we have created a connection, and we send the request and we receive the response here. So let's try to run it, and it starts our emulator, and let this to install our application in app sample. So before you run this application, we have to make sure go into applications and check whether you have installed App Store Simulator. If you open up, it will show you some simulation configurations. So once you installed it, you can open up in app sample, and let's see what happens. Once you click this purchase button, it asks you press continue to confirm the purchase, and it maps our sample application name and $0.01. So once you press confirm, now the App Store, the user have to be signed in. So for simulator we can use user and 123, and it shows the payment option. Select one of your payment option, and there we go, you have been successfully charged $0.01. So let's see what happens to our application. Yes, that increases our coins count. So let's try it again. Continue, mobile account, and confirm, and successful, and there we go, 200 coins. So let's check what happens if you switch back to simulator and set up insufficient balance response in our simulator. So it should give us insufficient balance response while we purchase. So switch back to our in-app sample. Let's try to purchase, confirm it, and mobile account, confirm. There it says insufficient balance in your account. So I hope you can see how simple this integration of in-app purchasing for your Android application. Okay, so let's end this session with looking back on some benefits of in-app purchasing with mobile account. Being a developer, you can increase the conversion rate of free users to paying customers, and you can target a wider market. For example, you can target teenagers who don't own credit cards, and of course there are people who are reluctant to expose credit card information. And with Android applications, you can offer a compelling and convenient experience to maximize the revenue potential. On the other side, if you take telcos, they can increase mobile payments done with mobile accounts and the ability to increase conversion from lead to sale. And of course, these cash calls are exposed to simple Android applications as well. That concludes our in-app purchasing session, and I hope you guys are excited now and going to start with in-app purchasing. Okay, move on guys and check out our in-app purchase APIs in DevSpace. Go to devspace.sendinmobile.com, and hope you guys enjoy these sessions. Thank you.